Let me talk a little bit about capacitance. This is the formula for capacitance, okay? And when we talk about capacitance, of course, we're talking about a capacitor, okay? And I'll pass around some capacitors. Basically, a capacitor is something that stores a charge, okay? It's like a battery, only it's much more temporary than that. And this is the formula for the capacitance of something. And basically, it's how much charge you can store divided by the pressure that it takes, the voltage that it takes to store that charge. Okay? A simple capacitor is just a couple parallel plates, like a metal plate and another metal plate. And the closer you put them, the better the capacitor is. And the way it works is this: is that if I put a negative charge on this plate, it induces a positive charge on that plate, right? And then I can store the charge on there. And the closer it is, the easier it is to induce a charge on the other plate, and the bigger the capacitance. And capacitance is in something called farads, but most capacitors that you have in any piece of electronics is in microfarads. Okay? Right? Remember, micro is 10 to the minus sixth, right? And then there's also picofarads. Picofarads. And those are the little bitty capacitors that might be like in your iPod or something like that. And pico is 10 to the minus 12th. So imagine what a farad is. I think I've got one that's close to a farad. And you can like weld wire together with it. It stores so much charge on it, right? I'll show you this. They're very cool. And so, is there anything else I need to say? I don't think so. Okay, so let's do a calculation with this, right? And we're using this in context with charge-coupled devices. Every pixel acts like a little mini capacitor. Not a very big capacitor, as you can see. And I don't know if that's realistic, but I think that's about what it is, right? So remember, the formula is capacitance is charge divided by voltage, right? Okay, and so let's see, we are trying to find the voltage. What is the voltage across it if it's been charged with 6 times 10 to the 4th electron charges? And this is, by the way, the electron charges are caused by photons hitting the CCD device. Right, the photons go in and they knock electron holes off, and that's stored as charge like on a capacitor. So let's see, I think we want to know, I think the first thing to do is to find the charge, right? Charge is 6.0 times 10 to the 4th electron charges, right? Times 10 to the minus 19th coulombs. We need the charge in coulombs, right? So 6e4 times 1.602 e minus 19. And this gives us a charge of 9.612 times 10 to the minus 15th coulombs. Now we're set. Now we can use our formula, and we want to know what the voltage is, right? So the voltage is going to be charge divided by capacitance, right? So that's going to be 9.612 e minus 15th coulombs, and then that's divided by the capacitance, which is 1.7 e to the minus 12th farads, and a coulomb per farad is a volt. Okay, so I'm going to divide this guy by 1.7 e minus 12, and I get my answer is 0.005654 volts, and then millivolts is 1, 2, 3, right? So it's about 5.7 millivolts, right? Yay? Because a milli is 10, milli is 10 to the minus 3rd, okay? Yeah, try some more of these things. They're not really very hard.